Hi guys, welcome back to Pypro versus YouTube channel where curiosity meets the core. Today we'll be seeing how to create an interactive animated spiral using Python. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions so I can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code, starting with importing the necessary libraries. You can see there is only one library imported, which is Turtle, which allows Python program to use Turtle graphics for drawing. And moving on, we have constraints, where all the necessary constants are been. Expansion include five colors are red, green, blue, orange, and purple. These lines define constants used in the program and represents the initial radius, angle increment, and all that colors. Colors are also listed for drawing of the spiral. And if you move on to next, we have initial turtles where we have screen is equal to turtle.screen. This line creates a turtle screen object which represents the graphics window where the turtle will draw. And we have screen dot setup width 600, height 600. This line sets up the and height of 600 pixels. And we have screen dot title interactive animated spiral. This line sets the title for the turtle graphics window to interactive animate spiral. And we have screen dot bg color as black. This line sets the background color of the turtle graphics window to black, and we have pen is equal to turtle dot turtle. This line creates a turtle object named pen which will be used for drawing on the turtle graphics, and we have pen speed 0. This line sets the drawing pen to the turtle to the maximum speed, causing the turtle to draw as quickly as possible. And we have pen dot hide turtle. This line hides the turtle icon from viewing, leaving only the drawing visible on the screen. Next, we have a function called draw spiral. So here starting with df draw spiral, radius, angle step, expansion step, and colors. This line defines a function named draw spiral that takes four parameters, which is radius, angle step, expansion step, and colors. This function will draw an animated spiral using the turtle graphics. And we have angle is equal to 0, color index is equal to 0. This line initiates variable angle and color index to keep track of the angle and color of the spiral. And we have a while true loop. This line starts an infinite loop which will continue indefinitely until the program is terminated. And we have pen dot color, color index, the color of the turtle to current color in the colors list based on the color index. The modulo operator, that is the modulus, ensures that the index loops back at the beginning of the list if it exists the length of the list. And we have pen dot circle radius dot extent is equal to angle. This lines draw a circle with the current radius and extent specified by the angle. The extent parameter determines how much of a circle to draw effectively, controlling the spiral pattern. And we have angle plus is equal to angle step, radius plus is equal to expansion step. These lines increment the angle and the radius variables to change the shape and the size of the spiral in each iteration of the loop. And we have if radius is greater than or equal to 300, and we have radius is equal to 50, angle is equal to 0, color index plus is equal to 1. So this if statement resets the radius, angle, and increment of the color index when the radius exceeds 300. This effectively restarts the spiral rounding process with a new color. Let's move on to the next function, which is change expansion speed. So let's see what change expansion speed does. So starting with df change expansion speed, this line defines a function named change expansion speed, which will be called when the user wants to change the expansion speed of the spiral. And we have global expansion increment. This line declares that the expansion increment variable inside the function is global variable, allowing it to modify within the function. And then we have to give expansion speed is equal to screen num input change expansion speed, uh, followed by enter new expansion default is 5. This line prompts the user to enter the new expansion speed using the dialog box. The num input method of the screen object displays the prompt with a default value of 5 and returns the user input as a floating point number. Then we have a if loop where if expansion speed is not none, expansion increment is equal to expansion speed. This if statement checks if the user entered a value that didn't cancel the dialog box. If the value is entered, it updates the global variable expansion increment with a new expansion speed. So let's move on to the next function, which is change color. So as usual, df change color. This line defines a function named change color, which will be called when the user wants to change the color used for drawing the spiral. And we have global colors. This line declares that the colors variable inside the function is a global variable, allowing it to be modified within the function. And we have colors is equal to screen text input change color, enter the color separated by commas, example red, green, blue. This line prompts the user to enter new colors separated by columns using the dialog box. The text input method on the screen object displays the prompt and returns the user input as a string. And later we have a if loop, if colors is not none. That is, if statement checks if the user entered a value that is didn't cancel the dialog box. Then we have colors is equal to colors dot split comma. This line splits the user input string into the list of colors using split method and divides the string at each comma. And we have colors is equal to colors dot strip for colors in colors. This line uses a list of comprehensive to remove any leading or trailing white space from each color. So the next part is register keyboard bindings, where we have screen dot listen. This line tells us the turtle graphics window to listen for events such as key presses or mouse clicks. And we have screen dot on key press change expression speed E. This line binds the change expression speed function to the E key, where E is pressed and the function called to change the expansion speed of the spiral. And we have screen dot on key press change color C. This line binds the change color function to the C key. Where the C key is pressed, the function will be changing the colors used for drawing of the spiral. Later, we have to start drawing the spiral. So we are using draw spiral, initial radius, angle increment, expansion increment, and colors. And we are having keep window open, which is screen dot main loop. Here, screen dot main loop, it will tell us this line starts the main event of the loop turtle graphics window, keeping the window open and responsive to user interaction unit manually. So let's quickly see the output of the program. So as usual, I want to go where the program is stored, copy the name of the program, open the command prompt in the same window, cmd and the python space file name dot py. You can see there is a red, green. If you want to change the color, you can use see, and you can, if you want to change the speed, you can use the E button on your keyboard to change the speed as well. Thank you so much for watching. If you have learned something from this video, please do like, share, and comment down. Thank you.